behavior is absolutely fascinating. And a fascinating application of human behavior is looking at gambling. If you were to walk around the floors of Vegas just watching people spending their money, you see just money disappearing out of people's hands. And these casinos are designed to not lose money. The casino is always going to win. Yeah, somebody might win here or there, but in the long run, the casino absolutely is going to come ahead. So how is it that people, buy into this whole idea that gambling is a losing endeavor? Because lots of people gamble. So much money is gambled away. And the people gambling are not the winners. So there's this whole industry of gambling, whether it's the lottery or in casinos, and we rely on people not understanding that whole law of averages. Because people seem to think that, okay, if you lose a lot, eventually you'll have to start winning to average out. But I'll go ahead and tell you, nobody's going to gamble enough individually for their law of averages to level out. It's not enough. So, getting 6 tails in a row, most people would think that the next toss has to be a head. The law of averages has to happen. Well, no, the next coin just as easily could be a tail. Okay, that coin doesn't know what happened last. And same with the casinos. The slot machine doesn't know what happened last. So, yes, in the very, very long run, the heads will have to appear half the time. But what happens in the middle, stuff happens. You can have 6 straight tails. You can have 10 straight tails. You might even have 300. Now, 300 might be getting a little less probable, but this making up for these imbalances doesn't happen in such a short time. It has to happen in the long run. So think about this. After 10,000 tosses, do those first 6 tosses even matter? And no, they don't, because it took those 10,000 tosses are going to overcome. We are overwhelming the next results, not compensating. And that's a huge thing. So this law of averages really isn't the way that we understand the law of averages. What really it is the law of large numbers. Okay, the law of large numbers states that in a large number of independent repetitions of a random phenomenon, like coin tossing or like rolling a dice or something that's just truly random and independent, averages or proportions are likely to become more stable as the number of trials increases. Okay, so this law of large numbers really doesn't apply until you've done something many, many, many times. And what's even crazier about this law of average is even though the proportion or the average tends to level out, the sum or the count actually becomes even more variable. So we can see that with our coin toss. We did the one on the left, but if instead of us looking at the proportion of heads, if we were to actually look at the sum or the total number of heads, you see that it starts out somewhat steady and then it really becomes a big variation here. And what's happening there is still this law of large numbers. The count becomes even more variable as time goes on. So we can also think about probability in terms of meteorology. And if you watch the video from the Against All Odds, you looked at how meteorologists are making these predictions and what a probability in a forecast really means. So if a meteorologist said that they were predicting below average snowfall this winter, and he says first in looking at the past few winters, there's been above average snowfall. So even though we're not supposed to use the law of averages, we are due. Okay, no, you cannot use the law of averages if you're only looking at the last few winters. If you were to look at the last 1,000 winters, then yes, maybe things would level out. But the next year is unpredictable. We don't know based on what's happened in the last few times. So probability just doesn't work that way. Each observation is random. We don't have a predictable behavior in the short term. Now, certainly with meteorology, they are using more than just guessing. Okay, there are models that they use, but they are not making those guesses based on things like the law of averages. They're using other types of data that is more reliable. So using the law of averages like this doesn't make any sense when talking about the weather. And I do want to talk about one last thing with our understanding of probability is we also use probability for our personal probabilities, and that's a whole different type of understanding of probability. So a situation like this, somebody watching the Chicago Cubs, they lose another game, and we asked Joe, what's the chance that the Cubs will go to the World Series next year? Well, he's going to make up some number. He says, about 10%. Okay, that is a personal probability. That's just something that he is imposing based on his understanding of, his idea of likelihood. Okay, so the outcome of next year's World Series it's unpredictable, and we can't even talk about something like that in many repetitions. So these personal probabilities really aren't true probabilities because they aren't referring to long-term behavior. So personal probabilities really are just personal judgment. So be careful when you see people assigning a probability in this personal case, because it's not really what probability is. So if you want to look at the idea of personal probability, it's just an outcome. It's just a number from 0 to 1 that expresses an individual's judgment of how likely the outcome is. It's not the true definition of probability. And an application of that whole personal probability helps us understand how people evaluate risk. Okay, so personal judgment of how likely something happens and what happens in many repetitions are two different ideas. And that's part of why the public and the experts really don't agree on what's risky and what isn't, because people are putting a personal probability on something, but that's just their judgment, and it doesn't reflect this long-term repetition behavior. Experts use probabilities from data. When experts tell us what's going on with COVID-19 or what's going on with the flu or whatever the case is, they are using data. But individuals in society, we've got this habit of ignoring data. So you just kind of look around your world and you don't necessarily pay attention to the larger picture. And one other thing that's kind of interesting is we tend to worry about risks that almost never occur while ignoring others that are much more probable. And a way that you can think about that is the probability of you contracting COVID-19 at the grocery store is probably less likely than you having a car accident on the way to the grocery store. Now, I'm not saying that there's no risk in going to the grocery store during a pandemic. There certainly is. But we tend to ignore certain things that are actually quite risky, like driving a car. Driving a car is probably one of the riskiest things that you do. But we do it so frequently that we kind of are conditioned to not think about that risk. You can also think about things like asbestos. People really freak out about asbestos, and it is dangerous. If you get high exposure, it's absolutely dangerous. Low exposure, not really so risky. But we can look at the numbers, and a probability that a teacher who works for 30 years in school with typical asbestos levels will get cancer from the asbestos is about 15 in a million. But the risk of dying from a car accident is 15,000 in a million. So you have 1,000 more, like your chances of dying from a car accident is 1,000 times more. But we don't stop driving because of the risk, but we're willing to spend a ton of money to clean up asbestos. And so it's just this whole idea of how we have a hard time evaluating risk when things are uncommon. We tend to really hone in on that. Things that are kind of common to us, we don't always evaluate the risk there. Another thing is we worry about tornadoes and terrorists more than heart attacks. You are much more likely to get a heart attack than you are to be in a tornado or be in a terrorist attack. But we have to recognize that we feel safer when a risk seems under our control than when we cannot control it. So we feel like when we're driving, we're in control. Now, I'll tell you, we're not actually in control. You can't control the people around you, but you are at least in control of your vehicle. But things like asbestos or tornadoes or terrorists, we can't control that. And so we tend to have a hard time dealing with that. And there was an article, and I don't think that I can find it, but the great toilet paper shortage of 2020, where there was no toilet paper to be found in March and April. Why did that happen? There were a bunch of different things that occurred, but one of the things that psychologists are considering is that buying things like toilet paper, buying food, buying canned goods, it was something that we could do to control this unknown threat. We were facing this disease that we didn't know much about, and it was definitely everywhere we turned around, we were hearing it. It was causing us to panic. And doing all of that, purchasing, we felt like it was something that we could do to control the situation. So that, among a few other factors, are some of the theories behind what happened. And, I just think it's interesting how human psychology really plays into our understanding of probability.